Alright, so now that our height field is looking pretty cool, we can go ahead and cut out a cylindrical section like I've done in the shot here, because I think that's kind of a nice way to present this scene. And we'll also do some extra work to carve out the river area as well. So to carve out this tube cylindrical shape here, let's just create a tube primitive. And I'm going to set this up so that it always matches the size and position of the height field. So let's go to the height field, copy the center parameter. So copy parameter, go to the tube, paste relative reference in the tube center, and then go back to the height field, grab one of these size components, copy that parameter, and let's paste that relative reference into the radius scale. Paste relative references there, and let's template display this tube. And you can see that's actually twice as large as it should be because this is a radius, not a diameter. So let's just add a 0.5 multiplier on that radius scale, which makes this tube the right size, although it's still a tiny little skinny tube. So let's give this some height. Let's do like 500. Make this a polygon instead. Maybe solid template display this. Control clicking there. Let's give this some more columns and some end caps. And now, if we change the height field size or position, like if we change this up to 1500, then the tube scales as well, and it'll also follow it if we translate this around. Yay, proceduralism. Cool. Now we can use this tube that we've generated to cut out the height field just in that area. So let's type in cut, and you'll see height field cut out by object pops up. We can attach our height field in there in the first input, tube into the second input. Don't need to change any settings or anything on this. And if you display that, you can see it's cutting out this nice circular shape in our terrain. So the next step is to define where the river is going to be and to kind of cut out a recessed area that the river can flow through. For this sort of thing, I really like using some manual art directable input to drive this, and we're going to draw a curve to determine where this is going to be. So create a draw curve SOP, connect the height field into the first input. The first input is a projection object. And then on the draw curve, go to the projection tab and select under projection the geometry so that we can draw the curve directly onto that. And then display this draw curve SOP. And typically I think it should show the geometry here. I'm surprised it doesn't. Maybe it only works with polygons, but in any case we can solid template display the height field itself, hit enter in the viewport with draw curve selected. So that's going to give us the actual draw curve tool, and then you can draw where your river is going to happen just by dragging your curve across the surface. So if you look at that curve, you can see that is perfectly drawn onto this height field. Now this river path is a little bit too crazy. You might have a hard time getting this to simulate nicely, especially if this is going to be your first river simulation. You don't want to make your job too difficult for yourself. And also, we want to make sure that when we draw this curve, it's kind of in a sensible place. Like, this river currently would be flowing uphill in all sorts of crazy ways. We really don't want to have our river try to flow up like this. Although, this is an alien world's theme, and who knows what sort of crazy physics might be happening in this world. So yeah, feel free to get experimental if you would like. But for me, I'm just going to try to have this more rooted in some of the sort of physics that we would expect to see. So I'm going to kind of follow where we already have like a natural low point in the terrain here. After you draw some curves, if you want to erase those, you can go over to the stroke tab here and you can delete curves that you've drawn. And then I'm just going to go back over here and we're going to draw a new river. So I'll go like this. Actually, maybe I'll back up to where I can see the entire path properly. And I'll draw a curve kind of like so, following this recessed path that's already naturally in the terrain there. Something like that. Cool. So that seems like a kind of reasonable path. And now we can use this to push down that area in our height field. Now I've redrawn this curve a little bit because that first one I drew was looking maybe a little bit too unnatural for me. I think this one that runs a little bit more straight looks a little bit better. So I'm just going to delete that other curve and let's process this a little bit to create the region that the water is going to flow through. Now with these curves, if you need to change the resolution of this for whatever reason, whether it's too high res, too low res, whatever, or if you just want it to be more consistent, you can use a resample SOP. This will make sure that the distance between all the points is a certain length. Right now we're working at a pretty massive scale. This is 1500 units, so I would actually be afraid to display this resample at a resample length of 0.1. That might create a crazy number of segments. Actually, it's probably not too bad. Let's see. Yeah, that's pretty quick. That's much higher res than we really need for this. 16,000 points, but we don't need that much detail. Let's resample this to 10. And then let's do a poly wire to create some 3D geometry based on that drawn curve. Now that poly wire is going to, by default, give us a very skinny polygon tube that we can barely see. This is actually, a 3D tube being created along that drawn curve. So let's increase the size of this a bit. Maybe a radius of 40. Maybe let's do 10 divisions to round this out a little bit more. And this doesn't have to be beautiful or perfect. This is just going to give us the general region that we want to, create this recessed region. And let's also add some noise to this to make it, a little bit more of a natural organic shape. So I'm just going to add a mountain SOP to this. And let's just turn up the height to, let's try 60. And increase the element size as well for some more, kind of broad noise features there. I think that'll work just fine. Now we'll create a VDB volume from this geometry, an SDF volume that is. So, as you saw earlier, go to VDB from polygons, and you have to be really careful here. Now we're working at a large scale. This is 1500 units across, and VDBs are generally created with this voxel size setting to define the resolution. So if each voxel is 0.1 units by default, when you pass a really large object into this VDB from polygons, if it's creating a voxel every 0.1 units, that's going to create an insane number of voxels to fill up the space. And I've seen this happen in production a lot, where you have voxel size like this with a large object passed in, and it can instantly crash your Houdini session or sometimes your machine. So you have to be extremely careful here when you work at large scales. Now I'll start by putting in a larger number here, like 10, and if we display that, that's looking all right. This doesn't have to be a super high res volume. We could go down to a voxel size of 5. I think that'll be good enough. Once you start going fairly low with this, it still isn't too bad. You see this is 2.6 million voxels. That's not too bad. But when I set that down to 0.1, it didn't, crash my Houdini session or anything. And you can see this is an extremely detailed volume. But if I try to move around in my viewport, it's going really, really slowly because this is an incredibly heavy volume to compute and display. It was kind of slow to compute. I think that took almost 30 seconds. And if you middle mouse on this, you can see this is 263 million voxels. And I think my RAM usage jumped up quite a bit as well. So yeah, my computer survived this particular SDF, but proceed with caution at large scales. For our purposes here, I'm just going to use a voxel size of 5, since this doesn't need to be super accurate. And then I'm going to expand this SDF a little bit as well. You can use this VDB Reshape SDF node to expand that. Default operation is a dilation. I'll do a value of 3 to expand it a bit. You can also use this to erode instead of expand it. It's a very useful node in general. Super helpful when procedural modeling. And now we can use this SDF volume to create a new mask on our height field. So if you start typing in mask by object, here you've got height field mask by object. Drop that down. Let's connect our height field to that. First input is the terrain to mask. Second input is what we'll be using to generate this mask here. Now if you display that and turn the template off of the height field up here, you can see that this is creating this masked out region on our height field based on the SDF. Now we're going to push this masked down region downwards to create that recessed area in the terrain. But right now, this is a very hard edge along the edge of that mask. We want kind of a nice fall off to where this river is going to be. So on this mask by object node, we can turn up this blur radius to kind of fuzz out the edge of that mask there. I think maybe a value of 20 looks like a decent fall off. And then we can use a height field remap to kind of push that region down. Now, we only want to affect the areas in the mask. So right now, if we display this height field remap, it's not really doing much because it's just remapping this 0 to 1 range to 0 to 1. That's not actually changing anything. But if you remember us looking at our height field value ranges earlier, this goes up to around 170. So if we change the input max to about 170, then that's going to have a much bigger effect. But you can see it's squishing this down everywhere. And we really only want this to happen in the area that's been masked out. So like we have with the noises, we have the second input on the remap that is a mask input. So if you connect that to the mask by object, that means it'll only push down this region that we've masked out there. So we're already kind of starting to see this nice little area that this river can flow through. That's working pretty well, I think. We could push this down some more if we want to. You can kind of play around with these values to your liking to get this height field modeled in a way that looks like it'll be suitable to do our river simulation later. I think this is looking pretty good like that. And then finally, after doing all of this processing on these height field volumes, we can ultimately convert this to geometry. To get regular polygonal geometry out of this, you can drop in a convert height field SOP, and if you display that, now we'll get some regular polygons here. If you middle mouse on here, there are no longer those height field volumes. It's just standard 3D, polygons, points, and prims. And you can control the resolution of this a bit on this convert height field. So if you want a little bit more detail out of this, you could turn the density up a bit. So if we turn that up to 2, then we'll get a higher res result. I think this should work pretty well for our purposes. And this is giving us a lot of data that we might not need. This is a somewhat heavy mesh. It's like a little bit more than 2 million polygons. And any extra attributes we have on here are just going to make the geometry a little bit heavier to work with. So in this case, I don't think we really need anything on here except for the mask attribute perhaps, because this mask attribute is still set to be this river region there. And this is going to come in handy a little bit later for some additional processing. So I don't want to get rid of that attribute, but we can get rid of everything else. So let's drop in an attribute delete, and we can put stars inside detail to get rid of all detail attributes. And same thing with the prims. We can get rid of all primitive attributes. And for point, I'll put in star, but then this caret symbol and mask. So now if we display the attribute delete and check the attributes that remain on there, you can see it's just that mask attribute and our point positions. And yeah, now we've got some polygons we can work with, and we're going to do an extra cutout of that circular region again on these polygons, since that conversion to polygons doesn't actually respect the area that was masked out. You can see this alpha attribute that came through on this conversion to polygons is showing, it shows up a little bit darker outside of this, circular masked out region, but it's still giving us all of those polygons. So we do need to do a little bit of extra trimming, and we'll do some extra modeling type tweaks on these polygons as well to finesse things, and we'll save those updates for the next video.